All right. So type 2 cells are the same as type 1. We have inert electrodes, all right? But we're doing it in aqueous solutions. And because we're doing it in aqueous solutions, we need to account for water, okay? Remember, type 1 was molten salts, where you basically just melt them, so there is no water in solution. Type 2, we have water. So we have to look at the electrolysis of water, okay? If we go to our data package quickly, data booklet, and we go to the last page, reduction potentials. Okay. We have, where's water? So it's even, that's not what I want. Somebody help me find. Okay. Water can be reduced, all right? And it can be oxidized. So two things can happen. And where is it? 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 There's two different waters. So, we'll zoom in here for a sec. What is the difference between these two? So this one and this one. Sorry? One is way stronger. So this top one would be in what conditions? Acidic conditions. And this is? Neutral. All right? Because it gives you the proton concentration, 10 to the minus 7. So this is neutral. Right? If you take the pH of this, negative log of that, you're going to get 7. So it's neutral. I'm going to write this on the page. So, and there's one for the other one too. So this one that's highlighted here is neutral. And this one is basic, okay? So the ones with 10 to the minus 7 are neutral conditions. So let's fill those in. So the two reductions are 2 H2O plus 2 electrons, hydrogen gas, that is basic conditions. And then there is and the same reaction, except, and you should write 10 to the minus 7 molar. Under neutral conditions. Okay, so the basic has a potential of negative 0.83 volts, and the neutral has a potential of 0.41 volts. And then the two oxidations, same thing. You get two different voltages, but the reaction overall is the same. Has an E naught negative 0.82 volts, and that is the neutral. Saying rights before I even get to the. And this is acidic. All right. So depending on if you're in neutral, acidic, or basic conditions, you'll get different voltages. These are the only two reactions. These two right here. And remember, everything else on our table is standard conditions. What's the concentration for standard conditions?
25 degrees,
1 molar. And 1 molar, right? These are the only two reactions on that table that are not at 1 molar. All right, it's 10 to the minus 7 molar, which is neutral. All right, everything else is 1 molar. Okay, so the electrolysis of neutral water. We just throw water into a beaker, put on a couple of electrodes, and then flip the battery on. What happens? So, here we might as well just draw it. Carbon electrode, battery, carbon electrode, and you have water. Okay, this is neutral conditions. So, what happens at the cathode? Cathode is where reduction occurs. Go to your data booklet. So these are reductions. Which one's going to happen? This one or this one? Which one do you pull from the table? If I say it's neutral. Has to be this one. Okay? If you have to look at the conditions when you're dealing with water. Okay? If I tell you it's neutral, this is the one that we use. Don't worry about overpotential effect. We're going to deal with that later today. This is the reaction that happens at the cathode. Okay? And so the E naught, the reduction potential is negative 0.41 volts. So the cathode is 2H2O plus 2 electrons. And the E naught is negative 0.41 volts. Okay. The anode is where electrons leave. All right, so you get oxidation happening. If we go to the table, there's our two waters. What's the reaction? Top one or the bottom one? Bottom, right? Because we're neutral, so it has to be this one. Okay? And remember, so we have to flip it, right? When you pull it off and you rewrite it as an oxidation, because it's written as a reduction here, but we know it's being oxidized, so you have to flip that. So we go H2O and E naught is negative 0.82 volts. So the overall reaction, if you add them together, the electrons will cancel out. You're going to get 3 water molecules. Will be reduced to 1/2 O2 gas, hydrogen gas. You're going to have 2 OH minuses and 2 H plus, which we'll simplify in a sec here. And the E naught for the cell atom together is negative 1.23 volts. So if you simplify this, 2OH minus and 2H plus, that forms what? Two waters, which will cancel the water, two of the waters over here. So the simplified reaction will be one water molecule so you can reduce water to oxygen gas and hydrogen gas. What would be the danger there? Is there a danger with this? Oxygen and hydrogen, well, they're both flammable, right?
Yeah.
So if it's there any sort of spark or anything. All right? But we're not producing a ton of it. Okay? All right. Can I flip the page? How strong would the battery need to be? As long as it's bigger than 1.23 volts, you're good. Okay. Because this is just, we have a beaker full of water and we're running a current through it. Well, you could balance it and multiply 3 by 2. That's fine. Okay? No. We will, that's the next part. Okay. Okay. What if it's acidified water? You have hydrogen or protons added to it. Okay. So, at the cathode. Cathode is where reduction occurs. Okay. So if you have well, actually, let me write this out. So now we have water, but we also have H plus because we've added acid. Okay. So we go to our data booklet. Let's clean up this data booklet. Okay. And we're looking, we have to compare things now. So we have water, we have acidified water, which is, where is the acidified water? Up here. There. Right there it is, okay. All right. There's our acidified water, and we have protons. Okay. Okay. What's going to happen at the cathode where reduction occurs? Okay. Is water going to be reduced, or is the proton going to be reduced? Water? But is water on this side? Water's here. Water's being oxidized in this reaction. So this reaction is not going to happen. Okay, you have to look on this side where these are all the things being reduced. Okay, so we have protons here. So just keep going down till you find water, which is down here. But does this water work for us? Because this is neutral water. Okay, does this water work for us? Because that is basic, right? So what gets reduced at the cathode? The protons get reduced at the cathode. Okay, because they're the highest and strongest of the oxidizing agents. It's the highest one on the left-hand side. Okay? So, the cathode reaction is two protons. Yeah. Plus 2 electrons forms H2 gas. And the E naught of that is 0. All right. What happens at the anode? So the anode is oxidation. So go back to your data booklet. So you're looking at the right-hand side for something that we have. So we want to find water on the right-hand side. We find this. Does this work? Does that one work? Yes or no? Yes, because it's acidified and it's water. Now, what you have to do is look to see if there's anything that's on the right-hand side, that is lower, because the strength of the reducing agents increases as you go this way. So you keep looking. Is there any other water on here? We find this water. Does that one work? No, because that is neutral. Keep going. Is there any more waters on here? On the right-hand side. There isn't. Okay? So the strongest one and the one that happens is this reaction here. Okay? So the anode is H2O. Goes to 1/2 O2 gas. It's 2 protons plus 2 electrons. And because we flip the potential, it's negative 1.23 volts. Okay, if you add those together and simplify, you get this reaction. What do you notice about that reaction compared to the one on the previous page? It's the exact same with the same voltage. It's just something different is being reduced at the cathode. Okay? So it's not water that's being reduced, it's the protons that are being reduced to hydrogen gas. But you get the overall same reaction. Okay. So that's, sorry? Well, you're going to see it in a sec. Why that's important. Because it tells us that we have to account for the acidified proton. Well, the protons that are in solution if it's acidified, okay? Because when we do a salt, which we're going to do right now, where it's something dissolved in water, you have to account for everything and see what will happen. Okay, so now, if we look at the electrolysis, so before we did type 1 cells, we did molten sodium chloride. Now we're going to do 1 molar solution of, well, Na sodium iodide, same thing. Okay. And we're going to look at, did I miss? Oh, there it is. Okay. All right, I took that picture off on mine, but that's okay. All right, predict the chemistry in the electrolytic cell with internet electrodes in this. Okay, so 1 molar sodium iodide in solution. So there's a series of steps, but basically all you have to do is list out all your electrolytes that you have, okay? in the first step. So the first thing is we go, okay, we have sodium ions, we have iodine, and we have water. Okay? They don't say anything about it being acidified or anything like that, so we don't have to worry about that. It is neutral. I will say if it's acidified. Okay? So we have sodium, iodine, and water. What's happening at the cathode? So what happens at the cathode? Oxidation or reduction? Reduction. So we're going to go to our table or a data booklet. So we have sodium, iodine, and water. Now, let's just, before we do anything, let's just think about this. Of these three things, which is likely to be reduced, i.e. gain an electron? Sodium, does it want to gain an electron? It does, because it's positively charged, right? Does a negatively charged atom want to pick up another electron? Probably not. Does water? We know water can be reduced and oxidized. So really it's between these two, but we'll look for iodine too. So we're going to look on the left side, because we're looking for what is going to be reduced. The strongest ones are up high, and the weaker ones are low. So you want to find, of these three, which ones are the highest on the left-hand side. So really it's sodium and water. Those are the two you're looking at, right? Does everybody see those? They're down at the bottom. Okay? Water is there, picks up 2 electrons, produces hydrogen gas, and it's in neutral conditions. Sodium picks up an electron and becomes solid sodium. So, at the cathode, which one is more likely to be reduced? The top one, because that's the stronger one. So water will be reduced at the cathode. So the cathode reaction is 2H2O plus 2 electrons produces hydrogen gas and it has an E naught of negative 0.41 volts. Okay. The anode is where oxidation occurs. So we have sodium, iodine, and water. Can sodium lose another electron? Very unlikely, right? Have you ever heard of sodium plus 2? It's very, very unlikely that's going to happen. So really it's between these two. All right, there are negatively charged ions that can be reduced. There are on the table. So you always look for the highest and lowest on the left-hand side. Or for the anode, what is oxidized? So now we're looking on the right-hand side. Come on. After this. So we're looking for, what are we looking for? I minus, where's I minus? There's I minus. All right? And we're looking for neutral water, which is right there. Okay. Which one is going to be oxidized, the iodine or the water? Look at the strength of the reducing agent goes down this way. So on the right-hand side, it's the lower one. So it's the iodine that is reduced. Okay, that's the anode reaction. Because it's not on the right-hand side, because this is it being oxidized, right? Or sorry, reduced. This is water being reduced. You're reading it this way. Now we're reading it being oxidized. Water on this side of the table. There is no water, it's down there.
Oh, is it the same thing? Like, is the voltage?
You just flip it if you flip the reaction, right? Like here is the water on the right side, here, right? That's it being oxidized, but iodine is stronger. So iodine will be oxidized before the water is. If you run out of iodine, it would. But the iodine will all happen before the water.
So you're saying that equation is the same as the one at the bottom that you just put?
No. You talking about this?
Yeah, like how do you know when you
Well, if you're looking for something being oxidized, you have to look on the left-hand side and read it going this way. This way. You have to read it going this way because that's an oxidation reaction. It's losing electrons, and that's what we're looking for the cathode or the anode.
And you know it's losing electrons
Because when you read it right to left, it goes from 2I minus to
because. How do we know that iodine is losing electrons over the wall?
what?
How?
I don't understand your question. You got to say it.
Like, how do I know which ones should be on the right side?
The cathode is where reduction occurs. Okay? So cathode reaction will be the highest on the left side. The anode reaction, where oxidation occurs, is the lowest on the right side. I'll write that down. Okay? So the anode reaction is going to be 2I minus is that. So if you think of your table, cathodes are on this side of the table, the highest on the left side. Anode reaction will be lowest on the right-hand side.
So how do we know that the water that's below the iodine is?
Because it's not written on the right-hand side. Like you're reading it. This is water on the right-hand side as being reduced. You can't use these ones because that's it. Sorry, this is it being oxidized, losing electrons, reading it that way, right? Water being reduced is down here. It's picking up electrons.
When would that one?
What?
When would that one?
That is the cathode reaction in this reaction. Because you're looking for what's happening at the cathode. Okay, let me finish this and then I'll come talk to you. All right, so the overall reaction, just add these two together. So you're gonna get 2 water molecules plus 2I minus producing hydrogen gas plus I2 solid. So the E naught of this, if you add those together, is negative 0.95 volts. So at the cathode, where reduction is happening, you're going to have hydrogen gas being formed, so there'll be bubbles on this electrode. And at this cathode, you'll start to see iodine, solid iodine, which will then dissolve in the water, precipitating out here. All right? And so you get like a brown color forming, if you've ever seen solid iodine. Okay? So when you're picking what's happening at your anode or cathode, anode, you basically, or the cathode, we'll do first. Let's look at this whole thing. This is the cathode side, which is reduction. This is the anode side, which is oxidation. And you just look on this side of the table for the cathode reaction. If your substance isn't written on this side but is on this side, it's not going to be a cathode reaction. Right? And then when you're looking at the anode, you look at just this side, and it has to be written the way it is on here. Okay? And for the anode, you want the lowest down on the right, and for the cathode, you want the highest on the left. And that's how you pick it. Okay? Do you want to do one more? Or do you want to just try them? Okay, let's just try and see how this goes.